Okay, so this is going to be 3-6. Let's go ahead and write that on the top. 3-6, generate equivalent expressions. Our goal is I can identify and write equivalent algebraic expressions. Equivalent algebraic expressions. This one's a bit tricky only because we've got these different properties that we're going to have to use, and it can be kind of confusing. All of these properties that we are going to use have been taught to you in previous grades, but that doesn't necessarily mean you know them by heart. So we're going to go over those ones really quickly, and then we'll start using them to make equivalent expressions. Remember, equivalent meaning equal to. So we have equivalent fractions or ratios that are equal to each other, that just look differently. The first one that we're going to use a lot of is the distributive property. So go ahead and write distributive property. Distributive property. There's JoJo. And we talked about this earlier in the year. It's where we'll have like an addition or subtraction problem in a parentheses, and then we distribute another number that's outside of the parentheses that's being multiplied by that. So I'm going to give you what that looks like using just variables. So A would be the number that outside the parentheses. And let's just say we have B plus C inside. When you see this kind of setup here, initially what we would do is just add these B plus C and then multiply it by A. But if we don't know what the numbers are, we can write this as a different algebraic expression by distributing this A into the parentheses. I'm sure you've seen me do that before. So it would be A times B. So we put A times B over here. Plus, because it's a plus sign, A times C, because we're distributing that A to the B and to the C. So this would be A times C. So both of these are equal. Both of these will get you the same answer. And to prove that, let's just do a quick example. I'm gonna put over here just so I can save some room. So let's say we have 3 parentheses 4 minus 1. Well, initially we would just go, well, 4 minus 1, I'm going to do the parentheses first because order of operation tells me to do parentheses first. So 4 minus 1 would be 3. And then 3 times 3 is 9. That's the way we normally would do it. Here's how you would do it if it was the distributive property. I'm going to rewrite this. I'm going to distribute this 3 inside the parentheses here. So we've got 3 times 4 and 3 times 1. Well, 3 times 4 is 12, and 3 times 1 is 3. And then 12 minus 3 is 9. You see, we get the same answer, so that means that these are equivalent expressions. So this right here, this 3 times parentheses 4 minus 1, is the same thing as saying 12 minus 3, or 3 times 4 times 3 times 1. I know that seems like a lot of extra work, but when you throw in variables, it actually kind of like, oh, okay, I want to try to make this as simple as I can. So that makes a little bit more sense. But right now, you're saying like, well, why would you even do that? It's just so much simpler just to do this. Well, that's because I don't have any variables here. We will do more examples with variables. This is just refreshing your memory about distributive property. All right, the next property is the associative property, and the associative property is you could do addition and multiplication. Likewise, distributive property, you can do addition. Go ahead and write this in. Addition and subtraction. Meaning, in the parentheses, you could either have an addition sign or a subtraction sign, just like I have here. So there's the addition sign, here's the subtraction sign. It works either way, but yeah. All right, so then we have the associative property. And this is also addition, this is addition and multiplication. So in parentheses, put addition, multiplication. And these are really, really simple, basic, and you just don't know the names of it. Or some of you might not. I know I didn't for the longest time. This next one is A plus B in parentheses plus C is equal to A plus parentheses B plus C. Meaning you can put it doesn't matter which two you do first, it's all going to be, because it's all addition, it's all going to be the same answer. And again, let's see what that looks like when we actually put numbers into it. I'll just use the 3, 4, and the 1 over here. So parentheses 3 plus 4 plus 1. Okay, well that's 3 plus 4 is 7. Plus the 1 is 8. Okay, well what about if I did 3 plus parentheses 4 plus 1? Well, that would be 3 plus 4 plus 1 is 5. 3 plus 5 is 8. Ah, they're exactly the same. So these are equivalent, right? So I can put the parentheses around 3 plus 4 or 4 plus 1. As long as they're all addition, I'm going to get the same answer. So it doesn't matter where I put the parentheses. And again, this will come in handy when we have like variables and whatnot. And now the same thing works with the multiplication. So if I did A times B times C, it's the same thing as saying A times parentheses B times C. Remember that multiplication or addition, it doesn't matter what order they go in, because you're going to be multiplying and adding them no matter what. Now, subtraction and division, you can't do this. This is why it's only addition and multiplication. The other one is the commutative property. Commutative property. This is also addition, multiplication. Multiplication. And this is just normal. You know what this is. Sorry, my setup just fell. This is when you have let's just really simple, A plus B. You can switch them and you can go B plus A, and it's the same thing. Or if I have A times B, it's the same thing as saying B times A. That's the commutative property. You can flip them. And you see that here when you go 3 plus 4 is 7. And 4 plus 3 is 7. It's funny because that's you think oh well, yeah, that just makes tons of sense. I've always known that. That makes tons of sense. But you know, I'm working with Harrison on addition, and he's got to use his fingers for both of those, even though they're the same numbers, just flipped. It doesn't. You don't always just know that. You've got to learn it. And that's what you've done. All right, so those are the properties we're going to use: distributive property, associated property, and the commutative property. Now we're going to throw in some examples, and we're going to take problems that look like this up here. This 3 times parentheses 4 minus 1. We're going to throw variables in there, and we're going to break it down. We're going to distribute that 3 and then break it down so that we get to the answer, or as best we can, because we'll have a variable. We won't actually have an answer. But then we'll also take the answer, the broken down part, and then work backwards to get back to this. And that's where it gets a little bit confusing. So let's try some of these out. Again, pause anytime you need to. If I went too fast, pause, write down, and then hit play again. All right, so let's take that 3 times 4 minus 1 and throw a variable inside of it. So let's say we had 3 times 4x minus 1. Well, the distributive property here would be telling me to distribute this 3. Right? So what I really have is 3 times 4x minus 3 times 1. And then so this would be the distributive property here that I'm using. Distributive. I don't mind if we just start putting dp for distributive property, so we don't have to keep writing this out. And then what we're going to be doing here, where it's 3, look at this. This is really just 3 times 4 times x, right? Because 4 times x, that's what that says. 4 times whatever this number is. 4 times this number and then times 3. This is just 3 numbers being multiplied. We can use the associative property of multiplication here. And we're going to do 3 times 4 times x. And then 3 times 1 is just 3. So what we're doing here is using the associative property of multiplication. AP meaning associative property. So then we do 3 times 4, which is 12, and then that's our coefficient, 12x minus 3. And then that's it, because we can't go any further. It's broken down, simplified to as far as we can go, because we don't know what x is. Okay, well, check it out. Going back to what we had before we put a variable in, that's just what this is. Look, 12 minus 3, 12x minus 3. Now we just have a variable in there, because remember, the variable is just representing a number. It's just another number. Cool, so we use distributive property and we use the associative property of multiplication. Now let's use the distributive property and work backwards. This is the part where it could be a bit tricky. So let's say we had 2x plus 4. We want it to look like this. Remember, these two are equivalent. This 3 times 4x minus 1 is the equivalent to 12x minus 3. They are the same thing. If I plug in x, 2 for x here, I'm going to get the same answer I would get here if I plug in 2 for x. So I need to find the equivalent algebraic expression for 2x plus 4. And we're working backwards. We're using the distributive property, but working backwards. What we need to do is figure out what 2 and 4 have in common. What factor do they have in common? Well, the only factors that make up 2 are 2 and 1. And we don't want to use 1 because you'll just get the same answer. So let's use 2. Is 2 a factor of 4? Yeah, 2 times 2 is 4. So we're going to take out a 2 here. We're going to reverse distributive property. We're going to take it out. We're going to separate these. So it's going to be 2x plus 2 times 2. So we just use the distributive property. And we found a common factor of 2. Well, that's this right here. There's a common factor of 3. Right? I can take out a 3 here. So it'd be 3 times 4, as you see up here, and then 3 times 1. Well, that's what I just did. So I'm going to take that 2, put it outside the parentheses, and now take these 2 that are being multiplied by the 2, the x plus the 2, and now I've got an equivalent algebraic expression. And that's it. That's what we're doing right here. We're just finding equivalent expressions. Let's do a few more. I've also assigned to you the Virtual Nerd. It's on Pearson, and it's they usually have these instructors that are teaching you the same thing that I'm doing. They just, have a different way of saying things. And so I do recommend, they're 5 minutes long. I do recommend that you go and check those out. She breaks down distributive property, associative property, and she's really good. All right, let's do another one. Okay, let's do 4 times 2x minus 1. Well, we're going to use the distributive property here. I'm going to distribute the 4 times the 2x. Put my operation sign, the subtraction sign. I'm going to distribute the 4 to the 1. So 4 times 1. Now I've got, so that's the distributive property. Now I'm going to use the associative property of multiplication. So it's going to be 4 times 2 times x minus 4 times 1 is 4. 4 times 2 is 8. That's my coefficient because it's multiplying by a variable. I've got 8x minus 4. I can't simplify this down anymore. All right, let's do another one. Let's do 6 times n plus 3 minus 4. Ooh, what the heck is that minus 4 doing there? How does that come into play? Well, we're about to find out. So I'm going to use regular distributive property here. 6 times n, that's going to be 6n. 6 times 3 is 18, and I'm just going to carry that minus 4 there. That does not get distributed because it's not inside the parentheses. It's outside the parentheses, so it just stays as it is. Well, now I've got to combine these like terms. So there is no other variable with n, so this just stays 6n. But I have got two numbers here. I've got 18 minus 4. I can combine those. Okay, well, 18 minus 4 is 14. So I'm going to put a 14 there. And now I'm done. I can't simplify or combine any other like terms. All right, let's continue to do some more here. Let's figure out some. Let's do the ones where we have to work backwards. All right, so let's say we have. Let me scoot up my paper here. Oh boy, and there goes my setup. Oh boy, there we go. We're back in action. All right, number 5, let's do 8t. I'm just pulling these from the book here. I don't know why I put t. I don't like to use the variable t. All right, so we've got 8t plus 2. Because of the t and the plus sign, I mean, come on. What are they doing to me? We're working backwards now. We're doing reverse distributive property. We can't do these lines because there's no parentheses here. We've got like the final simplification here. Now we're working backwards. We're figuring out what numbers do 8 and 2 both have in common as a factor. Well, again, 2 only has 2 factors. 2 times 1. Is 2 a factor of 8? Yeah. 2 times what? Well, 2 times 4. So I'm going to put the 2 and then 4t in the parentheses plus 2 and then 1 in the parentheses. I'm just breaking it down into the factors. Well, they both have 2 in common as a factor. So I take it out and I write down as the factors. Well, 2 times 1 is 2, 2 times 4 is 8. Then I take that 2 and I put whatever's in the parentheses here into the parentheses, plus that plus sign. And there you go. Let's do one more where we work backwards. Ooh. Okay, so let's do, I'm trying to find one. Oh, here we go. One that doesn't have just 2 in it. It's a lot of examples with 2. All right, 5w minus 15. Well, again, 5, the smaller of the two numbers, only has 2 factors, 5 times 1. Does 15 have a factor of 5? Well, yeah, it does, 5 times 3. So let's break it down. 5 times 1w. That just looks weird, right? Because we don't usually put 1w, because 1 times w is just w. So when we go down here, that's what we'll put. And then our minus sign, and then we're gonna take out a 5 and multiply it by 3, because 5 times 3 is 15. We're just breaking it down by the factors. So then I'm taking that 5, putting it on the outside of the parentheses. There's my w minus 3. And again, and you can check this by doing the distributive property. So 5, if I'm distributing the 5 times w is 5w. 5 times 3 is 15. And there you go, 5w minus 15. You can see that they're equivalent, that they're equal to each other. All right, let's do a few where it's just like associative property or just commutative property, and we're simplifying here. Almost done. This is a long video, but almost done. Oops, number 7. Let's do... We have 5 7/10 plus 3z plus 3/10. Now there's parentheses around 3z plus 3/10. Now I'm not going to use a distributive property here because I have an addition sign here. If you notice, all the distributive properties, when we've been using it, simplifying, they've all been multiplication. 3 times whatever this is. 4 times whatever this is. 6 times whatever this is. And we're using multiplication, but if you look here, we've got addition. This is when we're going to use the associative property, meaning that I can rewrite this problem so that it looks a little different. I'm going to rewrite it as doing 3z on the outside of the parentheses, and I'm going to add the like terms here. And you're thinking, well, what the heck? Why'd you do that, Mr. Muga? Well, just think if that wasn't a z there. What if it was just 1 plus 3 plus 2, and I put the parentheses like that? Couldn't I just do 3 plus 1 plus 2? Wouldn't I still get the same answer? Oops, sorry. Well, yeah, because the associative property tells us that if it's all addition or all multiplication, I can put them in any order that I want. And so that works here. I want to get that 3z out of there so I can just add these two bad boys. Okay, well then I have 3z and then 5 and 7/10 plus 3/10. Well, that's really, I'm going to show you over here, but a lot of you guys just did that in your head. 7 plus 3 is 10, carry over, bring your decimal down. 5 plus 1 is 6. So really what this is 3z plus 6. This is using the associative property. I rewrote the expression to better to make it easier for me to add, to simplify. I'm trying to see if I have another one like that. I don't see any. Okay, so then let's do one that I think might be a bit confusing for you. We've got 3/4. Yeah, anytime you have fractions, people get crazy. And then we have, oh wait, look, this is an associative property, so this is cool. This is just associative property of multiplication. Then we've got parentheses z to the third, what the heck, times 4. Harrison, was that you, dude? Can you turn that down? So I'm going to rewrite this. I'm going to get that z to the third power out of there. And I'm going to multiply 3/4 times 4 over 1. Okay. Well, that still is z to the third. And this would be 3 times 4, which is 12. And then 4 times 1, which is 4. This would be z to the third still, to the third power. And then 12 divided by 4 would then be 3. And then I'm just going to combine these because this is just my coefficient now. This is going to be 3z to the third. So again, I use the associative property multiplication to rewrite it how I wanted to write it. And then from there, because it was easier for me to see now, I can just multiply these. 3 times 4 is 12. 4 times 1 is 4. Now I have z to the third times 12/4. 12/4 is really just 3. And then z to the third times 3 can be rewritten as 3 times z to the third. That right there is the commutative property. I just swap them. Z times 3 is the same thing as saying 3 times z. Sorry, I need to figure out how to spell commutative. Commutative property. These next ones here, really, I remember it really threw people off. What it is they give you an expression, and then they give you 3 multiple choice possible answers of the equivalent expressions. And there could be all of them. It could be all 3 of them that are equivalent. It could be 1, it could be 2, and you really just got to check. All right, so I'm going to do a couple of them because I know a lot of my kids struggled last time. So bear with me. I've got 5 times 2x plus 3. And then I've got down below that possible equivalent expressions. A is 10x plus 15. The next one is 5x plus 15 plus 5x. What the heck? And then 10x plus 8. Now, one of these is correct. Possibly 2, possibly all 3. We're just going to go and check, right? So I'm just going to use distributive property here first. I'm going to distribute this bad boy, this 5, into this parentheses. 5 times 2 is 10, which would be 10x. And then 5 times 3 is 15. Oh, check that out. It's that first one. It's like identical, right? So I know that one is for sure it. I also know that C can't be it because there's no way that I can get 10x and then 8 as my whole number over here because it's 15. There's no way that I can get 10x plus 8. What do you think their mistake was? Well, I could see it. They did 5 times 2 is 10x and then 5 plus 3 is 8. No way, Jose. Cross that dude out. Okay, so what about this one down here? Like, what is that? That pause is me trying to figure it out. It looks like they took 5x. They took that 10x and did 5x plus 5x. Does that work? Looks like it does, right? The 15 is still there. And then it just broke down that 10x into 5x plus 5x. So if I was to combine these, I just need to figure out if that works. 5. Let's just pretend like if that x was 2. And I did 5. Well, that would be 10 plus 10, which would be 20. Or it would be, yeah, it does work, right? Because that's the same thing as saying 10x. I'm sorry, 10 times 2, which is 20. So this is also correct. Sorry, that was me figuring it out on the fly. Yeah, 5 times x, 5 times 2, 5 times 2. If I add those up, that's 5 plus 5 is 10. The 2 stays the same. You wouldn't multiply the 2 because it's representing what x is. So it'd just be 10 times x, which is 10 times 2. This also works. Whew. Should have planned that out a little better. Let's do another one. Last one, and you guys are free to do whatever you need to do. Let's do, gosh, here we go. I looked at this one and I thought, I don't want to do this one on the fly, but here we go. I'm going for it. We have 12x minus 16. Here is a is 9 and 6/10 x minus 16 plus 2 and 4/10 x. This is very similar to one we just did. And then we have 3 times 3x minus 5. Then we have 4 times 3x minus 4. Now we need to figure out what these are. So I like to work backwards and figure out what factors, the reverse distributive property, what factors does 12 and 16 have in common? Well, for 12, I've got 3 times 4. Yep, 16's got a 4. We could use that. Look right here. There's a 4 right here. The other factor that they have here is 3, and 16 isn't. 3 is a multiple of 12, but 3 is not a multiple of 16. So there's no, yeah, because when I do this, 3 times 3 is 9x. 3 times 5 is 15, so that's 9x minus 15. So that cannot be it. And then, yeah, so then 12x, taking out a 4 from that would be 4. 3x times 3x minus 4 times 4. This would be 4 times 3x minus 4. And that's what I have down here. The other way you can do this is just distributing this. 4 times 3 is 12x, and then 4 times 4 is 16. And there it is. So this one is for sure it. Now we need to figure out is A. Is A that craziness with the decimals and stuff. Again, rearrange it. Use the associative property of addition. So I'm going to put these together because they both have the same variable. I'm going to add these bad boys together, and then I'm going to subtract the 16 here. Oops, that's an x. Well, adding these two, I'm kind of off the paper here. I got 9 and 6/10 plus 2 and 4/10. 6 plus 4 is 10 decimal, carry my 1. 9 plus 1 is 10, plus 2 is 12. This would be 12x minus 16. Is that this equivalent? It sure is. That is my, that is also a true expression, equivalent expression. So this is what we're doing. You're using the commutative property, the associative property, the distributive property, and you are finding equivalent algebraic expressions. You are combining like terms. Hopefully everything that we have covered here is what you'll be seeing in your actual practice. Again, if you have any questions, contact me through either Remind or Google Classroom. If we need to set up a Google Meet tutor session, we can. Look at the videos on Virtual Nerd for on Pearson. Those will help out too. Look at the tutorials. Really dig deep. You have today and you also have tomorrow to finish up the problems. And then we move on to 3-7, which is also simplifying using one more new property called the identity property, but we'll get into that later. All right, bye.